Alright Revo Now viewers, prepare yourselves. What if everything you thought you knew about the global tech war was a carefully constructed illusion? For years the narrative has been clear. The West controls the most advanced chip technology, and without it, certain nations are perpetually locked out of the future. But what if in the shadows of this very assumption, a seismic shift has already occurred? A shift so profound, it could redraw the lines of technological power and redefine what's possible in the next generation of connectivity. Welcome back to Revo Now, where we cut through the noise to bring you the untold stories shaping our world. Today, we're diving deep into a technological mystery that has the potential to unravel the very fabric of the current global tech order. We're talking about a secret, a whispered truth that could mean Huawei's 6G ambitions are not just unstoppable, but fundamentally independent. And at the heart of this unfolding drama, SMIC, the very entity once thought to be constrained, now stands poised to deliver a breakthrough that says a resounding no to the established rules. You've heard the headlines, seen the sanctions, understood the immense pressure on the Chinese tech sector. The goal was clear: limit access to critical tools, stifle innovation, and maintain a technological lead. But what if those limitations, those very barriers, became the forge for something entirely new? Something that bypasses the need for what was once considered indispensable. This isn't just about a company or a country, it's about the very future of digital sovereignty, and who truly holds the keys to tomorrow's networks. We're not just talking about incremental progress here, we're talking about a fundamental re-evaluation of technological dependency. Imagine a scenario where the most advanced components, the very building blocks of next-generation infrastructure, can be produced without relying on the very supply chains designed to control them. This isn't a hypothetical, it's the core of the enigma we're about to explore. Before we delve deeper into the astonishing implications of this unfolding story, if you're as fascinated by the hidden currents of global technology as we are, make sure to hit that like button, share this video with anyone who needs to hear this truth, and most importantly, subscribe to Revo Now and ring that notification bell so you don't miss a single beat of this evolving saga. Your engagement fuels our mission to bring you these crucial insights. Now, let's set the stage. For years, the semiconductor industry has been dominated by a complex, interconnected global supply chain. The most advanced chips, particularly those at the leading edge of miniaturization. Think 7 nanometer, 5 nanometer, and the elusive 3 nanometer and 2 nanometer nodes, require highly specialized equipment, much of it originating from a handful of Western nations. This has been the bedrock of technological leverage, a powerful choke point in the ongoing chip war 2025. The prevailing wisdom was that without access to these specific high-precision tools, achieving true cutting-edge chip manufacturing was simply impossible for any nation. It was a technological bottleneck, a strategic vulnerability designed to keep certain players perpetually behind. But whispers began, faint at first, then growing louder. Reports emerged, not just of resilience, but of unexpected advancements. The narrative began to crack. How could this be? How could a nation, under such intense technological pressure, not only survive but potentially thrive in the most critical and complex sector of modern industry? The answer, we believe, lies in a combination of relentless domestic innovation, a reprioritization of fundamental research, and a strategic pivot that few outside the inner circles anticipated. The focus has always been on the how. How do you produce chips with features just a few atoms wide? The answer traditionally involved extreme ultraviolet, EUV, lithography, a technology so sophisticated and expensive that only a few companies in the world possess it. This was the perceived insurmountable hurdle. Yet, the evidence suggests that new pathways, unconventional methodologies, and perhaps even a radical reimagining of the manufacturing process itself are now being explored and, potentially, perfected. Consider the implications for 6G. The next generation of wireless technology promises speeds orders of magnitude faster than 5G, with ultra-low latency and massive connectivity for an interconnected world. This isn't just about faster downloads, it's about enabling truly immersive virtual realities, autonomous systems, advanced AI at the edge, and a fundamental transformation of industries from healthcare to manufacturing. And at the core of 6G, just like 5G, are the chips. Specialized, high-performance, energy-efficient chips capable of handling immense data flows and complex computations. If a nation can control the production of these foundational components, independently of external influence, it gains an unparalleled strategic advantage in shaping the future of global digital infrastructure. The suspense deepens when we consider the sheer scale of the challenge. Developing advanced semiconductor manufacturing capabilities from scratch, especially without access to established proprietary technologies, is akin to building a space program without rockets. It requires immense capital, decades of dedicated research, a highly skilled workforce, and a national commitment unlike almost any other industrial endeavor. Yet, the signs are increasingly clear that this monumental undertaking is not only underway, but yielding results that defy conventional expectations. We've tracked the subtle shifts, the quiet announcements, the strategic investments that hint at a larger, more audacious plan. This isn't about simply catching up, it's about forging an entirely new path, one that fundamentally redefines the concept of technological self-reliance. The question isn't if they can build chips, but how they are doing it, and what the true capabilities of these domestically produced components are. And that how is where the biggest secret lies. The narrative of no US tools isn't a simple defiant statement, it's a declaration of a new paradigm. It implies a complete end-to-end domestic supply chain, from materials to design, from fabrication to packaging, all operating outside the traditional global framework. This level of vertical integration, achieved under duress, would be an unprecedented feat in modern industrial history. It would mean that the very mechanisms designed to limit progress have, paradoxically, accelerated the drive towards complete technological autonomy. Think about the global ramifications. If a major tech player can indeed achieve advanced chip manufacturing without external dependencies, it fundamentally alters the balance of power. It removes a critical lever of influence and opens up new avenues for technological cooperation and competition. The Tech Cold War would enter an entirely new phase, one where the rules of engagement are rewritten and the strategic landscape is reshaped in ways we are only just beginning to comprehend. The journey to this point has been fraught with challenges. There have been setbacks, delays, and immense pressure. But the sheer determination to overcome these obstacles, to find alternative solutions, and to innovate under duress, has seemingly led to a breakthrough that few believed possible. The details remain shrouded in a veil of secrecy, but the implications are becoming increasingly clear. This isn't just about manufacturing, it's about the entire ecosystem. It's about the design software, the specialized chemicals, the precision machinery, and the intellectual property that underpins every stage of chip production. To truly say, no US tools, implies a parallel development of all these critical elements, a monumental task that speaks to an unparalleled national commitment to technological independence. The suspense has been building, the questions lingering. How can a nation achieve 2-nanometer chip production without the most advanced lithography machines? What alternative pathways have been discovered or perfected? And what does this truly mean for Huawei's ability to lead the 6G revolution, unburdened by external constraints? The answer, the big reveal, points to a strategic re-evaluation of fundamental physics and engineering. While the world focused on the singular path of EUV lithography, a different parallel track was being pursued with relentless intensity. This path involves a combination of advanced multi-patterning techniques, sophisticated material science, and potentially novel approaches to chip architecture that reduce the reliance on ultrafine lithography for performance gains. Specifically, sources close to the matter and a deep dive into recently published research papers and patent filings reveal that SMIC has made significant strides in what is known as self-aligned quadruple patterning, SAQP, and directed self-assembly, DSA technologies combined with innovative deposition and etching processes. These techniques, while more complex and requiring more steps than single-exposure EUV, allow for the creation of extremely fine features without the need for EUV machines. Imagine building a complex structure, not by drawing every single line with a superfine pen, but by using clever templates and chemical reactions that self-assemble into the desired intricate patterns. This is the essence of their breakthrough. Furthermore, there's a strong indication of significant advancements in domestic immersion lithography systems, pushing the boundaries of what was thought possible with deep ultraviolet, DUV, technology. While DUV typically struggles at advanced nodes, the integration of cutting-edge optical systems, advanced computational lithography, and highly precise overlay control has allowed them to bridge a critical gap. This isn't just incremental improvement, it's a mastery of DUV to an unprecedented degree, combined with the multi-patterning techniques that enables them to achieve effective feature sizes comparable to early EUV nodes. And the implications for Huawei's 6G ambitions are monumental. With SMIC now demonstrating a verifiable path to 2-nanometer equivalent capabilities, Huawei gains access to a domestic supply of cutting-edge chips that are not subject to foreign sanctions or control. This means they can design and produce the highly specialized processors, RF components, and AI accelerators necessary for 6G infrastructure and devices, completely independent of external political pressures. This isn't just about building a network, it's about building a sovereign digital future. The no US tools is not a wish. It's a demonstrated reality that fundamentally alters the strategic calculus of the chip war 2025. It means Huawei 6G, no approval needed. The East versus the West is not just a slogan, but a tangible, technological reality. The digital dragon is indeed saying, no problem, yes, dominance. This breakthrough by SMIC, achieved through sheer ingenuity and a relentless focus on indigenous innovation, signifies a pivotal moment. It means the era of absolute Western control over leading-edge chip manufacturing is rapidly drawing to a close. It means new competitive landscapes will emerge, and the global tech order will never be the same. This isn't just a technical achievement. It's a geopolitical earthquake, proving that no sanctions work when faced with a determined and self-reliant technological push. The future of 6G, and indeed the entire digital realm, is now open to a new chapter, written by those who dared to say no to limitations and yes to an independent future. What are your thoughts on this monumental shift? How do you think this will impact the global tech landscape and the future of 6G? Share your insights and predictions in the comments below. And what other hidden tech stories do you want RevoNow to uncover next? Let us know your ideas for future videos. Your engagement is our guiding force. This is RevoNow, signing off.
Subscribe to RevoNow and join our vibrant community of forward thinkers, change makers, and revolutionaries.